See, I'm Mritunjay Singh. We are from British Telecom. I've got my colleague, Shankhanil Chowdhury.
Hi.
And I'm Principal Solution Architect within BT, but working on BT TV and broadband. And Shankhanil is the Specialist Solution Architect working on media and broadcast. So I would start off by saying that I was here last year at GraphTour, sitting in the back, and we had some use case in mind. We were exploring graphs, and we want to cover that now we are using it, and we have still not gone live, but we will be live in August. And we just wanted to cover what we have done with graphs within broadcast domains. Okay. So that's the agenda. I'll put the organizational context, where we belong within BT, because it's a big company. What was the use case within media and broadcast we looked at. My colleague Shankhanil will then cover on what specifically we did with graphs within the video delivery chain, and then what are our future plans with that. So if I take it, this diagram, we have got consumer-facing units of BT, and those consumer-facing units are retail, enterprise, and global services. And we then have, for all those three consumer-facing units, we have got BT technology, which is like an IT arm supplying technology solutions to all these three consumer-facing units. And we belong to the BT technology. And within BT technology, it's again being split between mobile, you can see voice, and TV and broadband. And under TV and broadband, we then have service platforms, which owns the back-end build of all work within TV and broadband. And media and broadcast is specifically a division concentrating purely on broadcast customers. So we carry, media and broadcast is 85% of broadcast traffic in UK is carried by media and broadcast. What we do is we provide the IT side of media and broadcast within service platforms. And that's where that's a specialist business unit within BT. And what M&B service platform does is, it is the managing of those networks and the IT systems which run over those networks to carry the broadcast traffic. So just to give a perspective, the topic said that how do we do path connectivity in a video contribution and distribution network? So this slide just gives a view of a video delivery chain, and I'll quickly go through this. So there is contribution, and what I mean by contribution is, if you see in that slide, it's an MPLS core network, but if you look at outside broadcast, so a match happening in a stadium in Manchester between Man U and Man City, we take that, and in that case, the customer would be Sky or BT Sport, whoever it is, but carrying that outside broadcast live from the stadium to some playout center, from where it then gets distributed to the customers. So we are involved in, that is called the contribution space. And then if you move from contribution to primary distribution, again, in the contribution space, it is also where we connect regional studios. So you could have a studio in Edinburgh, studio in Glasgow, studio in Channel Isles, and you want to bring from all those regional studios onto a central studio that again falls into the contribution space. Then coming on to the primary distribution, which is you've gone through the contribution, and now the diagram is saying like you've got satellites and you've got transmitters. So we try to take that content, which is gone through contribution, and we try to distribute it. But here we are not involved in the secondary or in the consumer side of the distribution. It is in the distribution where we take that content and carry it through whole of UK. And then from those transmitters, it will then be transmitted either via satellite, via terrestrial, through the distribution network to the consumers. But where media and broadcast plays is within the contribution and the primary distribution space. I work in a different division which also does the other side, but for me right now, as part of this is, our scope is in the video contribution and distribution space. So that's where we have got two networks, which is UK Media Network and Global Media Network. And what we do is we provide IT systems which do the OSS and BSS functionality over those media networks. This is just a view of our UK media network, which is built UK-wide. So this is different from the BT broadband network. It's an entirely different network. purpose-built to carry broadcast traffic, okay? So it's separate from 21CN broadband networks. It is an entirely different network. And then we've also got global presence. So you can see our global presence as well, which we call it as global media network. So it is UK media network and global media network, where we take UK-wide, as I told you, 85% of broadcast traffic. And then globally, we also compete with other competitors. But then we link, like we take content from Australia and we can move it to Asia Pacific in Singapore. It will go from Australia through UKMN back onto Asia Pacific. So this was the whole context. This is the business context. And what made us actually even think about graphs? So we had, 2 years back, our network, which is the UKMN core, was going end of life. And we had an opportunity it was running for 12 years, and we had to rebuild the whole network. So brand new core network. Brand new core network, we could have made a decision and said, use the existing OSS, BSS stack, the way we have been working for 12 years, and we just build a core network, and we move the services there. But then we said, that's not where we want to be. We wanted to do something where we are there for another 10 years. And this is what is describing. We then said, we went to our business-facing unit, which is enterprise, and we said, what do we actually want out of this? So there are some key business drivers, which is we wanted to increase competitiveness and our customer experience of how we offer these services to our customers. And we wanted to improve the operational effectiveness and data integrity. What that meant, I will not read through the slides, I'll just explain them. So we looked at those opportunities. Those opportunities then translated into some key system requirements. And if I look at those key system requirements, we said, okay, it's a modular architecture. Then we wanted adoption of microservices. But important one was we wanted a network topology and a dynamic inventory. And we felt Graph is well suited around having that. We wanted something which is, because the network is a graph, so it lends well into a graph database. I can make the network built into a SQL or a NoSQL database, but it lends well into a graph database. And we would put a lot of energy in actually running it on a SQL or a NoSQL database, but I felt graph would be a better solution. And then we wanted to have, I saw other speakers were saying graph is like you can traverse relationships deep. We would have relationships where customers have services, they are running over our network, they are carrying, and the relationship goes from a customer right up till to a port. We want those relationships to be managed, and if anything happens down, we want to understand how it maps to our customer as well, which will be covered by Shankhanil in detail. But these were our key business drivers. I'll now hand over to Shankhanil, where he will pick up from how these IT system requirements, along with some of our architectural principles, and how we did the path computation bit on the graph. Okay.
Thanks, Jay. So as part of that OSS transformation that Jay talked about, we had some functional and non-functional architecture requirements. And this is a subset of those requirements that drove us to use Neo4j. So the first requirement was layering. We wanted the network layer and the service layer to be separate, but to have relationships between them. And that was important from an ops point of view. That was important from service fulfillment point of view. And we'll talk about the details later. Service fulfillment, in our case, needed a real-time end-to-end path computation for a service. And that was a real-time requirement. It needed to work on the state of the network as of now. So it needed to be fed, and it needed to ingest the live topology and calculate a path on top of that. We also needed to improve our operational response to issues. So we wanted to provide ops with an enriched and correlated alarm instead of just bombarding them with hundreds of alarms when things go wrong, and that causes chaos. They run around trying to figure out what the issue might be, right? The top non-functional requirements were obviously resilience and availability, which can be achieved in Neo4j. We wanted development flexibility. So we have mapped out a lot of use cases for Neo4j, and we wanted the ability to quickly deploy those services and functionalities on top of Neo4j. So kind of like a microservices architecture. And we wanted to minimize the system integration costs, and Neo4j allowed us to do that, right? Because that becomes a central inventory and the topology state, and you have lesser interactions in that scenario. So I'll talk about the first use case, and the first use case was computation of a path. So what we did was, with Neo4j, is ingest a snapshot of the current topology, and we created a path computation service that uses the graph libraries in Neo4j. We tweaked those graph algorithms a little bit to fit our use case and introduce these constraints that we see here. So these constraints are required from a customer perspective as well as from a BT perspective. The first is node and link level diversity. We want the primary service tree to not share any fate with the protected service tree. So nodes and links used in the primary are not used in the secondary path. We wanted to take in cost as an account, which is a composite function of latency and bandwidth. We wanted to optimize the bandwidth. We wanted the tree to split as late as possible in order to optimize the usage of bandwidth across the core. And finally, we had MPLS constraint, which says if you're traversing a graph, don't loop around and revisit a particular node, right? And all of this needed to be done in milliseconds because our target for our customers was immediate provisioning and setup of services. The second one, I talked about the layered resource and service inventory. What we did in Graph is we created a physical resources layer, which has things like chassis, ports, and circuits, and define the relationships between them. A chassis contains many ports carry circuits, etc. We had a logical resources layer, which are the logical resources we built on top of these physical resources. For example, VRFs. We had the services layer that says which logical and physical resources are linked to a particular service. And we had the customer layer, which said this service belongs to a specific customer. And we did that to facilitate root cause analysis, service impact analysis, feasibility check for services, reservation of resources, and obviously for service fulfillment. So, and the last use case we explored with Neo4j was, from an alarms perspective, we wanted service impact assessment. So what we want is for an enriched and correlated alarm, a meaningful alarm to reach operations. In Graph, that is fairly easier and straightforward to do. So because we have that layered architecture where you have network, services, and customers, if we have a node failure somewhere, we can just query that node, the graph, to say which services are running on this network node. And from the services, you can find out which customers own these services. So in that way, what you have is you have an enriched alarm that reaches operations that tells you what went wrong and what are the services impacted and who are the customers you should engage with. And that, again, needed to be, the call and response needed to be in milliseconds because every second counts in a scenario like that. So future plans, so these are the things we did on graph databases. We are not production yet. We're not in production. So we are doing some proof of concepts we are trialing it out. We want to do some failure injection tests. We want to deploy it into production. We want to enhance the SIA and PCE. And there's many use cases that we have in mind, microservices that we want to build on top of Graph to provide more functionality. Plan engineering works analysis, what-if scenarios, et cetera, can all be built on top of this. Finally, we want to ingest live topology state into Neo4j and probably upgrade to version 4.0. And yeah, that's everything. So if you have any questions.
No questions. I'd just like to add that one of the reasons of going for Neo4j, we talked a lot about microservices, we talked a lot about the details, was the existing OSS BSS stack was a lot of COTS products. And we felt that this is our business logic, which is lying within customized code within COTS products. And the intent was we take that business logic and we own that business logic. So we use COTS product where it is relevant. So like using a graph, I mean, obviously BT as a company, we are not going to invest in graph. We're not going to build graph databases. So you take that from the market. What is critical to us is that business logic of how we compute path with node and link diversity. That is logic which we know well, how, and our network engineers will tell us how do we do node and link diversity. So what that meant is we employ open source technologies. Obviously, we are buying enterprise license, so there will be support of that. But we have control over the logic which we own, which we can expand and build upon in the future as well.
Yeah. If there's no questions, then thank you.
I mean, we'll be there in the common area.